Okay, so this video is just to provide a little clarification to number 27. Um, you guys didn't do 21, but the work I have for it to find the intersection points is here because it was the same as question 21. Um, so you just set them equal, divide the 4 over, you get sine 2 theta is a half. Well, sine's going to be a half when you have a 30-degree reference angle, so we want to think pi over 6, 5 pi over 6 divide by 2. So that gives us pi over 12, 5 pi over 12 for those two intersection points. So that's where the pi over 12 and the 5 pi over 12 are coming from. Now, I think it's almost always a good idea when you're working with a polar problem, graph it on your calculator just to get a visual of what's going on. So here's what's going on here. We wanted the part that was interior to both of them, so kind of like this here. And so we're just going to do one of them and multiply by 4. So uh, what I'm going to do is kind of uh, draw a more emphasized version of that region. So here's like a more emphasized version of that region. So our region that we're trying to trace is here to here and then there. So those purple lines aren't actually graphed, but that's as if you had gone straight out from the origin to those. Um, here's kind of another emphasized region. Really, the red in this one matches the red here, and the blue matches the blue. Okay, so the colors match up. So I kind of made the red parts go out a little bit further than they really do here, just to kind of emphasize it. So again, this is the red and the blue here matches the red and blue there that we're tracing, and that's the area that we actually want to find. The black lines I just put in to show you how the regions that we're going to find are divided. Now it's important to remember when polar curves are being plotted, the points are being plotted as you go around a circle and your angles are getting larger. So like the first thing we would plot right here when theta is 0, and then these are getting plotted as you go around. So if we look at this here, the stuff that would be getting plotted first is all the points on the red. And then when we get to that first intersection point, it switches and we're doing the ones from the blue curve. And then when we get to the second intersection point, it switches and goes to the red curve. So here's the overall picture here. So we first find the area of the sliver of the red part. So the sliver of the red part would be like this. Again, I made it a little bigger here to emphasize it. And then it's like the pizza slice or the pie slice of the blue part. So the area that we're getting from the blue part should not have curved edges because it's like a pizza slice. And then we have the red part area that we're finding. And that's what is set up here now. So you're doing the area of the red little sliver, the pizza slice, and then the other red sliver. And we have each of our intersection points as we go through. We can do that. And then at the end, we've just got to multiply by 4. Probably I should have put the multiply by 4 in front of the whole thing, the whole way down. But then that gives us for the whole thing. So hopefully that provides a little bit of clarification for question 27.